Welcome to Cheenta Statistics and Data Science. Today we are going to solve this problem from ISI MStat 2016, problem number 2 from the PSB section. So the problem says that determine the average value of I1 I2 plus I2 I3 and so on up to I9 I10 plus I10 I1 taken over all permutations I1 I2 up to I10 of 1 through 10, right? So we have to calculate the average value of this expression over all the permutations of 1 through 10. So initially, it might seem that this is basically a combinatorics problem, right? But we can actually solve this problem using probability. Let's see how. So let the population be this 1 through 10. So the number of ordered samples of size 10 that can be taken using SRSWOR, that means simple random sampling without replacement, it's 10 factorial, right? How many samples can be taken of size n, of size 10? Ordered samples, that means the order in the sample is important. 10 factorial, right? There are 10 in total, there are 10 factorial samples possible of this configuration, this size 10 and ordered and without replacement. So let xi be the ith sample element, right? Fine. Then obviously xi is follow discrete uniform over this set 1 through 10, right? Let x1 be the first sample element, x2 be the second sample element, and so on. X10 be the third 10th sample element, and so on. So obviously x1, x2, and x10 up to x10, these are all identically distributed over discrete uniform over this set, right? But they're not independent because we are talking about without replacement. So obviously they are dependent, right? But they are identically distributed. So basically what we want is the expectation of this thing x1 x2 plus x2 x3 and so on. Basically this is an isomorphic problem, you can say. The problem, original problem, and this problem is basically the same but in a slightly different form. So now we have to find the, since we are asked to find the average value, that means the expectation of this thing, right? X1 takes each of the 10 values with equal probability, x2 also takes each of the 10 values in equal probability, and so on. But even though they are identically distributed, they are not independent, right? And we are have to find the expectation of in this entire expression, right? Now obviously since they are identically distributed, then therefore the expectation of this thing and expectation of this thing, in the expectation of individual these things are actually the same. That means this is nothing but 10 into expectation of x1 x2, right? Because obviously x1 x2 and x2 x3, they are all identically distributed, they have the same expectation. That means this is nothing but 10 times expectation of x1 x2. So all we have to do now is find the expectation of x1 x2. Now for that we need the probability distribution, the joint distribution of x1 x2. Now x1 x2 is basically what? It's nothing but probability x1 equals to x1 and x2 equals to x2 is actually by the multiplication rule, you can say probability x1 is equals to x1 times probability x2 equals to x2 given x1 equals to x1, right? Which is nothing but the first one is obviously 1 by 10 discrete uniform. Now given that x1 has already been taken, x2 has equal probability over all the 9 remaining elements, which 1 by 9. So ultimately it's 1 by 90. This is the joint distribution of x1 x2, 1 by 90, where each of x1 and x2 both lie between 1 and 10, but they are not equal. In case of equality it becomes 0, because obviously since if x1 takes certain value, then the probability of x2 taking that particular value is 0. We are talking about without replacement, right? So expectation of x1 x2 is nothing but summation over x1 running from 1 to 10, summation over x2 running from 1 to 10, x1 into x2 plus probability of the joint distribution. The joint distribution is the PMF of the x1 x2, where x1 is not equals to x2. Now this entire, obviously this is obviously is equals to 1 by 90. So taking this out, this is nothing but summation x1 running from 1 to 10, x2 running from 1 to 10, x1 x2 without any restriction, no restriction on x1 and x2, minus the equality, the same thing. We are basically writing this thing as separately as summation x1 x2 minus summation x1 x2, where x1 and x2 are equal, right? We this is an algebraic manipulation. This can easily be understood if you write it in a slightly expanded form. So this is nothing but 1 2 up to 10 whole square plus minus 1 square plus 2 square up to 10 square. This ultimately turns out to be 88 by 3. Now this is the value of expectation of x1 x2, but we need the expectation of this thing. So this is what? 10 times expectation of x1 x2, and therefore expectation of this entire thing is nothing but 880 divided by 3. So this is the value of the, this is the average value of the expression that we are about, that we were asked to told, that we are asked to calculate, right? This is the thing. So basically, what we did, we just created an isometric problem, an isomorphic problem for this problem, a problem which is basically fundamentally same but in slightly different form, and we did this problem using probability, right? At first, it was a combinatorial problem, but now it is a probability sample survey problem, right? So this is a very interesting problem. This is a very interesting problem. So now we know the solution to this problem, right? After after you know that you have to calculate the expectation of this, after that it follows very easily, because you can easily calculate the PMF and all that and expectation. It's very easy. So only thing that you needed to know was that you need to find the expectation of these things, right? This is the only thing you needed to understand. So there you have it, the solution. See you till next time.